but there's only one way to find out. Let's get into it. So, this is kind of an interesting one. I mean, in this case, we're basically given this really long string, and it's all zeros and ones, as binary tends to be. And basically the idea is that it's like a bunch of blocks of, well, bytes, octets, like 8 bits, 8 characters that are zeros and ones. And we basically want to take every one of those and convert it into a letter. So it's kind of like we've taken a message and we've converted it to just zeros and ones. So this, in case you didn't know, is just another way of saying hello. This is considered the polite way to say hello for a lot of programmers. Anyway, the point is, so how are we actually converting this? Like a string of 8 zeros and ones doesn't necessarily seem like it would be a letter. So that's where the ASCII table is coming into play. We're basically representing each of our letters using the number, the ASCII code for it, but then we're converting that into binary. So that's the idea behind this one. Oh, and I forgot to mention, it's part of an escape room challenge. So let's try to get out of here alive. All right, so basically, there are a few ways we could look at this one. I mean, we could basically just sort of like break it down into like sets of 8 characters and then deal with those individually. So, should we start with that? Yeah, let's start with that. Okay, so basically, what we want to do is kind of split this thing up, right? So let's, first of all, we'll make a variable for our message, our hidden message, and it's just going to start as like an empty string, but ultimately it's the thing that we're going to be returning at the end. So let's just get that in there real quick. And now basically, how are we going to do this? Well, we could actually like cut it up, we could like do some sort of split technique on this and try to get it into like an array of characters, but we could also just iterate through it in a way that just sort of takes 8 characters at a time. So like what I mean by that is we could say something like for let I be assigned the value of 0, I is less than code.length. It was normally we would do I++, but instead let's do I plus equals 8. So it doesn't just go to the next one, it goes to, it moves 8 spaces over to get to the next one. And then, oh, hey, what was that all about? Okay, just a sec. Okay. Sorry about that. All right. So, where were we? Oh yeah. So basically, what we want to do here is we actually want to take like the byte, the octet, the set of 8 characters. So we're going to say let byte be assigned the value of code.slice. So we've seen slice before. Basically, it's something we can use for arrays. It's something we can use for strings, and it basically just it takes a byte out of it of a particular size, beginning at a certain index, and it just returns that part of it, or at least as much of that part of it as it can. So just to sort of remind you of slice, let's just start by just return code.slice, and let's just go from 3 to 7 here. And basically the idea is we're just getting 0, 1, 0, 0, so that's this part right here. So it begins at index 3, right? Because we'd have index 0, index 1, index 2, index 3, and then it ends before index 7. So index 7 would be this one right here. It does not include that one, but it does include the one at index 3. So it's got index 3, 4, 5, and 6, not 7. That's basically the way it's going to work. Now we've seen also before, like we can use fewer arguments, like we could just start at index 3 and just go on all the way to the end. So that's basically just taking off the first 3 characters. Or we could even give it 0 arguments at all, which kind of seems weird, because it's just returning the same thing. It's like, why would you do that? Usually this is used for just like making a deep copy of an array or something like that. But we don't need that for now. What we want to do is we're going to use two arguments because we want it to have a distinct starting place and ending place. So where do we want it to start? Well, I, right? That's our starting place. It's starting at 0. Eventually it's going to be 8. Then it's going to be 16, etc. So it's going to start at I. It's basically going to end 8 characters after that. So I plus 8 is what we're going to put after that. So that's byte. Let's just start by doing a little console log of byte. We'll see what we're getting here, and we'll see if it looks good. So yeah, all of these seem to have 8 characters. There are all these binary numbers here, and there's something we're maybe noticing about these. Like pretty much every single one of these seems to start with a 0, and we might think, well, that's kind of weird. Like, why bother with oh, what a reference. Anyway, like, yeah, why bother with this if they're all going to start with 0? Why not just make it 7 characters? And basically the reason is we want to represent this as a binary number, but when we look at our ASCII codes, like any of the characters we're going to use, any of these word characters, basically stop at 127. So it's not going to go beyond that. And 128 would be like 1, 0, 0, 0, 0. So anyway, that's just a little pattern notice, I guess. The point is, what we want to do with these is we want to convert them from binary into decimal, into not binary, into our regular base 10 number system. That's basically our goal. So we could do this in a few ways, like we could try to do this totally mathematically. We could run through it, go from like right to left, and just raise it to the appropriate power each time, sort of thing. But there's actually this nice built-in that we have. So we've seen parseInt before, right? You'll notice, well, actually we can't really notice this very easily, but these are all strings right now. Whereas when we run this code, so now with our console log of parseInt byte, it doesn't really look much different, except something you might notice is it's dropped the leading zeros here. We don't have any more leading zeros anymore, so now they actually are up to 7 characters long. These are actual numbers now. They're not just strings containing digits. But they're still not really what we're looking for, and that's because these are coming from a base 2 number system, and we want to represent them in a base 10 number system. So the nice thing about parseInt is we actually have a second argument we can use, and it represents basically the base we want to use. So right now it's 10, so if I change this to 10, it's not going to make any difference. They're going to look exactly the same. But since this is base 2, let's switch that over to 2 and we'll see what we're getting from those. So, okay, 72, 101, 108, 108, 111, 33. These seem a little more like what we'd expect, They seem, well, actually, let's take a look. So we've got 72. 72 is capital H. 101 is lowercase e. 111 is O. What were the other ones? Yeah, a couple 108s for the L's, and then I forget the last one, 33. So I'm assuming that's the exclamation point, but let's just verify that. It's the exclamation point. Okay, cool. So basically, we have the numbers we're looking for. We just need to get those in the form of characters, one character strings, basically. So let's just say let character code be assigned the value of parseInt of byte with a second argument of 2 representing the base. And then we'll say let character be assigned the value of string dot from character code. So we've seen this before. It's kind of like, we've used dot character code at to convert a string to a number, and we're using this to convert a number to a string, specifically character code. That's what we want to put in there. Okay, and then basically we just want to say message plus equals that character. That's essentially all we want to do here, and yeah, that does it. Okay, cool. So we're getting the right message out of each of these. Passes all the visible tests. Let's see if it's going to pass the hiddens. Ooh, nice. Okay, so that's good. Feels great, actually. So let's close that. Let's go back to the description for a second. We're not done with this. We want to look at this in a couple other ways. So first of all, I'm looking at this one, and I think it's kind of nice that, it's jumping 8 at a time. That's it's not too intensive or anything like that. We're doing this dot slice here, and I'm thinking, okay, slicing it up a little bit. We're doing a parseInt. We're doing this kind of stuff. I mean, we probably can't avoid doing a string dot from character code unless, well, yeah, someone probably has some clever way of avoiding that. But anyway, I don't, so we're going to use that. But we're going to look at this in a different way. So I sort of mentioned it before. We can just sort of do this mathematically. Like, we don't have to actually rely on the parseInt thing here. And, you know, if we can avoid it, maybe it's worth it. I don't know. It all depends. Like, if our code is going to be more efficient, then yeah, or if it's nicer to look at or something like that. Let's find out. So basically, we're going to start in a similar way. We're going to say, let's take this message thing, and ultimately it's the thing we're going to be returning. So far, no real difference. But the way we're going to go through it is going to be different now. So I actually want to start at the right now and go to the left. And basically, I want to say, okay, well, let's take a look at our first number. So that's 8 right there. So for our first number, remember, for binary, like, this is the ones. Okay, just to contrast with the decimal, like normally this would be the ones, that's the tens, the hundreds, thousands, 10,000, etc. But for binary, it's not powers of 10, it's powers of 2. So it's going to be like 1, 2, 4, 8, 16, 32. So basically this one is just a 1 and a 32. Add those together, we have 33, and that was what we're looking for, right? That was the exclamation point that's being encoded at the end of this message. Okay, so that's basically what we want to do. We want to go through it from the right, and for every time we cross or traverse one character, we want to be incrementing the power of 2 that we're looking at. So let's actually start with that. Let's say let power be assigned the value of 1. And we're going to be building up a character code as we go through this. So we'll say let character code be assigned the value of 0. So we had character code down here, but now we're just going to build it up sort of one step at a time. So let's see how that works. For let I be assigned the value of code.length minus 1. Because remember, we're starting at the end now. And we want to iterate until I is no longer greater than or equal to 0. And by the way, super important that we remember the minus here, not a plus plus. Our code would go on forever otherwise. You'd have an infinite loop and no one would be very happy about that. Okay, so basically what we want to do is just grab the character at the end and add it to our character code. So we'll do something like this. Character code plus equals, power times code at I. All right, and you might be thinking, well, is that okay though? Like, isn't code at I, isn't that part of a string? And yeah, it is. So, you know, look, if it would make you happier, we can put a parseInt on this thing. We're not going to actually need the parseInt because, like, you can't multiply letters together, right? So it's going to say, all right, well, this thing's a number, that thing's a letter, but it's this thing's a number. Wait. Okay, not a letter, but a string containing a number. This thing's a number, this thing is a string containing a number. The way it's going to look at this is you can't multiply a number by a string, so we might as well just typecast this to a number and try to do it that way. JavaScript's like really forgiving that way, which is nice, but you know, don't get too comfortable or anything. A lot of languages are not forgiving like that. So it's probably a good idea to put in the parseInt here. I mean, it's probably more clear to the reader that way anyway, and like, it has, like, the JavaScript engine has to typecast this thing anyway, so I don't think this is like any less efficient, aside from just being more characters. So anyway, I think we've probably said enough about that, and then we'll get to this point afterwards where we basically want to multiply power by 2. So we'll do power times equals 2. Power times equals 2. We'll look at another way we can do that in just a sec, but before we do, I just want to talk about what we're going to do after this. So we're building up our character code, but the thing is, we don't want it to just build up forever, right? Because it could get pretty damn big otherwise. So we want to cut it off at the appropriate spot. So as soon as we notice, oh, hey, we've actually gone 8 characters in, then we want to say, oh, okay, reset everything, get the string, or get the character that has this character code, and then basically restart the process. So this is how we're checking. If we can divide this number by 8 and there's no remainder, then we've sort of reached a point where we should be cutting this thing off. And just to sort of demonstrate that, like, you know, if we're going from the right, then the last time we're going to want to cut this thing off is when we get to 0. The second last time is when we get to an index of 8. the third last time is an index of 16, etc. So all of those are multiples of 8. So if we divide them by 8, we get a remainder of 0. So using a modulus in here. And then basically we just want to say let character be assigned the value of string dot from character code. And what are we going to do with that character? Well, basically we want to put it onto the message. So message plus equals character. And then we want to reset everything else so that it doesn't just continue to grow. So we specifically want to say power is going to be 1 again, and character code is going to be 0 again. Otherwise, we get some pretty weird characters in there. In fact, well, okay, hold on. Let's just run this first. And oh, all right, we're getting the mirror image of what we want. So really, it's not that we want to do message plus equals character, because remember, we're going from the right here. We want to say message is assigned the value of character plus message. So the character we're getting should go to the left of what we have already. So let's try that. And there we go. Nice. I'm actually kind of curious. I just want to see what's going to happen if we don't reset these things. I have a feeling it's going to be catastrophic and we're going to see some really weird stuff. Okay, yeah, so there we go. Oh yeah, that's, I think I prefer it this way. Anyway, so yeah, we can see that these things are definitely important. All right, now it's been a while since we've talked about shifts, like binary shifts. You can shift a binary number. So what I mean by that is, like, let's say you had something like, okay, hold on a sec. We need a really sick color. Okay, good. So let's say we had something like 1 0 0 1 0 1. Okay, if we were to shift this left, let's say one unit, then it would basically all the bits would go to the left. So instead we'd have 1 0 0 1 0 1 0. And basically this is like a whole nother number. It looks really similar. It's like, oh, didn't you just put a 0 at the end? But it's gonna look really different. It's not as simple as just like in a decimal number when you put a 0 at the end. It's just like, yeah, you multiply by 10. So this is a bit different. I mean, yeah, essentially we're multiplying by 2, but it's kind of like, instead of having a 1 and then, oh, my mouse died. Okay, we're good. Instead of having a 1 and then a 4 and then a 32, so what would that be, 37? Instead of that, we're going to have a 2, then an 8, and then a 64. So what would that be? I'm not good with numbers, but I think 74 or something like that. Anyway, the point is we're shifting it that way. And essentially it's another way of just multiplying all the bits by 2. So we could do that instead of this, you know, like we could say power is assigned the value of power shifted left 1 unit, and it should run exactly the same way when we do that. But keep in mind, that's kind of the same as doing power assigned the value of power times 2. But I didn't say it this way before. Before I said power times equals 2, because that's a more efficient way of doing it. Could we do that with this? Could we say like power left shift equals 1? Like that seems kind of strange, but will it work? And the answer is yeah, it works. So that's something I actually didn't know about until I was, you know, preparing for this problem. So it's kind of cool. I think this is kind of neat. I actually sort of like this this algorithm a bit better than the one below. I realize we're not really like making use of all of our built-ins here. Like it would be more efficient maybe to use our parseInt with the second argument of 2, but I just kind of like the sort of mechanical way this one's approaching the problem. I think that's kind of neat, and I guess I have a soft spot for sort of more mathematical based algorithms. But anyway, the point is, do it how you want. You know, if you prefer this, that's fine. If you prefer this, that's fine. But there's another way we can do this. So I'm going to wrap this one up again, and we're going to try yet another algorithm. And I think this is going to be the last one. Now let's see if you can take a guess. We're dealing with a string here. We're trying to figure out some kind of property or pattern about a string. What are we going to use? Yeah, you guessed it, a regular expression. So basically, our regular expression here is going to be, it's going to be something like this. So let's just write out the excuse me, let's just write out the regular expression first of all. Well, first of all, we want to have some options, right? What options do we have for our characters? Well, 0 or 1, that's pretty much it. How many of these are we going to have? Well, we're going to have 8. That's kind of a constant here. We're going to have 8 of these things. So our regular expression, I think, is just going to be this. I don't think it's going to be any more complicated than this. So we could do something like, let's try this. We'll say return code.match with this regular expression, 8 characters that are either 0 or 1. Let's see what happens with that one. And okay, it's finding that first one. It's finding the first one. I don't want it to find just the first one. I want it to find all of them. So let's put the G at the end there. And now, great, it's finding all of them. So that's actually what we were looking for from the very beginning. Something that could actually split apart this thing into distinct groups of 8 characters. And what a way to do it, right? I mean, that's nice and efficient and cool. So we could do something like this, you know, do like a dot map on this, like map these to be their characters and then join that at the end. In fact, might as well do that, right? So let's just do dot map, and we'll go with, we'll call these byte. So byte is going to get mapped to string dot from character code of parseInt byte with a second argument of 2 for base 2. Close up the map there, and we'll do a dot join with an argument of empty string because we don't want there to be anything in between. We're just going to join them up, and that works. You know, so like that's a totally fine way of doing it. And I guess that means actually this is not going to be our last one because I didn't actually even think of doing this before. So I have another one ready to go. So instead of this, instead of doing like the dot map and stuff like that, we're going to do a dot replace. So let's say code dot replace. So it's just going to take every one of these things that it sees, every one of these like bytes, every octet. It's just going to grab each one of those and it's going to replace it with what? Well, we've got to reformulate this a bit. It's getting kind of crowded in here. So we want to do a dot replace. The first argument is going to be the regular expression that we want to find, the thing that we actually want to replace. The second argument, well, we could just put something that we want to replace it with, like let's say an exclamation point, just for emphasis and enthusiasm. And there we go. But that's not really, you know, great. We want it to actually depend on what we matched here. We want it to depend on what we found. And so the way we're going to handle that is we'll say, okay, well, we'll do a function here. And as its argument, it's going to take in the byte, you know, the thing that got matched to the regular expression here. Now, keep in mind, this is the whole thing that it matches, whereas if we put a second argument in there, it would be for a capture group, but we don't have any capture groups in here, no parentheses necessary.